A simple statement is a statement that makes only one assertion. This assertion may be true or false. This is a true statement, but this statement is false. Complex statements are made up of simple statements. When the connecting word is "and," the complex statement is only true when statement A and statement B are both true. When the connecting word is "or," the only time the complex statement is false is when both simple statements are false. Think of it this way. Either water freezes at 32 degrees, or it boils at 80 degrees. Well, yes, that's true, because water does freeze at 32 degrees. As long as one part of an "or" statement is true, then the entire statement is considered true. We can graph x is greater than 2 on a number line. We know that x cannot equal 2, so we put an open circle at 2. The graph shows that any number greater than 2 will make this a true statement. The arrow tells us that the solution continues past the numbers we can see. We also know that x values less than 2 will not work. In algebra, complex statements are made of two or more simple algebraic statements. And or work just as they do for verbal statements. We can graph this complex statement. First, we'll draw the graphs for each of the simple statements. We'll put them just above the number line, so we can put the solution to the complex statement on the number line. Since the connector is "and," the complex statement is true only when both statements are true. This is where the two lines overlap. Here's how we graph it. Any value between 2 and 4, but not including 2 or 4, will make this a true statement. Watch what happens to the complex inequality when you move the points on the graphs of the two simple inequalities. Let's graph this "or" statement. Again, we start by graphing the simple statements. Since the connector is "or," as long as one of the simple statements is true, the whole complex statement is true. So this complex statement is always true. Use this number line to experiment with and or in different inequalities. Watch how the graph changes as you change different parts of the inequality. We can graph x in Watch. Let's graph this.